Imagine standing on the sidewalk of Manhattan, looking up at a $1.8 billion skyscraper that pierces the clouds like a shimmering needle of glass and steel. It is a monument to modern engineering, a height of architectural prestige where the cheapest penthouse costs more than most people earn in a lifetime. But while the world admires the sunset reflecting off its facade, deep underground, something is going catastrophically wrong. Below the marble lobby and the high-speed elevators, the very foundation of this massive structure is beginning to fail. This isn't a slow theoretical change that will happen in 100 years. It is happening right now. Residents are reporting mysterious popping sounds in the middle of the night. Long, jagged fissures are snaking across the basement concrete, and high-precision sensors are detecting a tilt that shouldn't exist. This is the story of a megaproject where ambition raced ahead of geology, and now, a nearly $2 billion pillar of luxury is quite literally cracking under the pressure. Today we are going deep into the structural nightmare of one of New York City's most expensive failures to understand why you can build to the heavens, but you can't ignore the dirt beneath your feet. To understand why this disaster started, we have to look at the unique and often treacherous ground that Manhattan is built on. Most people assume the entire island is a solid block of granite, but that is a dangerous misconception. Manhattan's bedrock is a patchwork of solid schist, soft marble, and pockets of ancient swampy silt that have the consistency of wet clay. When this tower was conceived, the developers were in a race for height. They wanted to build taller and thinner than anything nearby to maximize those views of Central Park. But the specific lot they purchased sat right on an ancient geological fault line, where the solid rock drops off into a deep basin of soft, unstable sediment. Normally, you would drill piles hundreds of feet down until you hit that solid rock. But in the world of high-stakes real estate development, time is money, and the cost of drilling through that much sediment was astronomical. The decision was made to use a different, more controversial foundation design, and that single choice is what set the timer on this multi-billion-dollar ticking clock. Instead of securing the building to the bedrock, the engineers utilized a system known as friction piles. Imagine pushing a chopstick into a bowl of thick honey. The chopstick stays in place not because it hit the bottom of the bowl, but because the honey is gripping the sides of the wood. That is how this tower was supposed to stay upright. The friction of the surrounding soil was calculated to hold the weight of thousands of tons of steel. But there was one variable the engineers didn't account for: the changing water table of Manhattan. As new construction projects went up nearby, and as the city's ancient subway tunnels were pumped out, the moisture level in the soil changed. The honey, so to speak, became more like water. The friction began to fail, and once a skyscraper starts to settle unevenly, gravity becomes a relentless enemy that never sleeps. You might be wondering how the residents of a billion-dollar building react when they realize their home is sinking. It started with small things. A door in a luxury suite that used to glide shut would suddenly hit the frame. A kitchen cabinet would pop open on its own during a windy night. But then, as the building began to tilt by just a fraction of a degree, the problems became audible. Skyscraper frames are designed to flex, but they are not designed to be under permanent, uneven torsion. People living on the upper floors began to hear what they described as gunshots echoing through the walls. These were the sounds of massive steel bolts shearing off under the immense stress of the building's lean. When a building of this height shifts by even an inch at the base, that movement is magnified at the top into several feet of sway that the dampening systems were never built to handle. The panic behind the scenes during these early failures was intense. The developers didn't want the public to know. If word got out that the foundation was failing, the $1.8 billion valuation would vanish overnight. They tried stealth repairs. They brought in teams under the cover of night to inject high-pressure grout into the soil, hoping to solidify the ground and stop the sink. But the problem with injecting grout into unstable soil is that you can't control where it goes. In some areas, the grout just followed the path of least resistance, flowing into old sewer pipes and basements of neighboring buildings, causing legal chaos for blocks around. Instead of stabilizing the tower, they were literally pushing the problem into the rest of the neighborhood. This is the point where the megaproject transitioned from an architectural marvel into a legal minefield. The homeowners, some of whom are billionaires and heads of state, formed a coalition to sue the developer for over $600 million. They aren't just complaining about the cracks. They are complaining that the elevators, which are designed to travel in a perfectly vertical shaft, are now bumping against the guide rails because the building is no longer straight. Imagine paying $50 million for a penthouse and having to deal with a vibrating elevator that sounds like a freight train every time you want to go home. The luxury dream has become a logistical nightmare of epic proportions. The engineering challenge to fix a sinking skyscraper in the middle of a dense city like New York is almost impossible to visualize. You can't just lift the building up. It weighs hundreds of millions of pounds. Some experts have proposed a process called underpinning, which involves hand-digging new shafts beneath the existing foundation while the building is still occupied. It is like trying to replace the wheels on a bus while it's driving 60 miles an hour down a crowded highway. The risk of a localized collapse during the repair is so high that many insurance companies refuse to even provide coverage for the work. This left the tower in a state of paralysis. Too dangerous to leave alone, but too risky to fix. As we look at the broader context of Manhattan's Billionaires' Row, we see a pattern of hubris. These super slender towers are a new breed of architecture. They are taller and thinner than anything humans have ever built for residential use. This requires a level of precision that doesn't leave any room for error in the foundation. In the case of this $1.8 billion tower, the pursuit of the ultra-thin look meant the building had a very small footprint relative to its height. This created a lever effect on the foundation. When the wind hits the top of the building, the pressure on one side of the foundation becomes immense. If the ground underneath isn't perfectly solid, that pressure will eventually crush the soil, leading to the tilt we are seeing right now. The structural cracks in the basement tell a terrifying story of the physics at play. These aren't just hairline fractures. In some places, you can fit a hand inside the gaps. These cracks show where the massive concrete mat of the foundation is literally being pulled apart, because one side is sinking faster than the other. When concrete is under tension like that, it loses its strength. The engineers have had to install massive steel collars around the support columns to prevent them from bursting. It looks less like a luxury tower now, and more like a patient in a permanent neck brace. What makes this a true failing megaproject is the financial trap it has created. The building is currently unsellable. No bank in their right mind will issue a mortgage for an apartment in a building with a documented foundation failure. This has trapped some of the wealthiest people in the world in a vertical sinking ship. They can't leave without losing $50 million, and they can't stay because the building's systems are failing. It is a spectacular example of how even the most powerful people are ultimately at the mercy of the quality of the construction beneath them. The city of New York has also been forced into a difficult position. If they declare the building unsafe, they have to evacuate a major part of Midtown. If they let it stay, they are taking a gamble on the engineering fixes. So far, the Department of Buildings has allowed the tower to remain open, but with the condition of constant 24-hour monitoring. There are lasers and sensors placed all over the structure that will trigger a citywide alarm if the tilt moves by even a fraction of a millimeter more. Living in the tower now means living with the constant reminder that you are part of a massive, high-stakes experiment in structural failure. The environment around the building has also changed. Deep rumblings are sometimes heard by pedestrians on the street. These are subterranean shifts in the soil as the weight of the tower continues to compress the layers of clay. The groundwater in the area has been diverted, which is causing older, smaller buildings nearby to settle in ways they never have before. The tower isn't just failing on its own. It's taking the neighborhood's stability with it. It is a geological ripple effect caused by $1.8 billion of misplaced weight. Why wasn't this caught earlier? The answer lies in the way these mega projects are approved. Often, the soil reports are done by private companies hired by the developer. There is an inherent pressure to find good news so the project can proceed. In this case, early warnings about the depth of the bedrock were reportedly downplayed or dismissed as overly cautious. By the time the foundation was poured, the momentum of the project was too great to stop. It is a classic case of the sunk cost fallacy. Literally, they had already spent hundreds of millions of dollars on the foundation, so they felt they had to keep going, even if the ground was shaky. As we examine the interior damage, the tragedy becomes more personal. Luxury finishes like hand-carved Italian marble and custom-built cabinetry are being ruined as the building's frame shifts. Because the building is leaning, the drainage systems aren't working correctly. Water from sinks and showers is pooling in the wrong corners of the pipes, leading to smells and blockages that no plumber can fix. It's a bizarre reality where billionaires are living in conditions that feel more like a dilapidated apartment complex, all because the fundamental geometry of the building is off by an inch. The mechanical systems are also under extreme stress. The heating and cooling for a building this tall require perfect pressure balance. But because the shafts have tilted, the vents and ducts are leaking air. This makes the building incredibly loud. Residents have described a constant moaning or whistling sound that never stops. It is the sound of the wind fighting against a structure that is no longer aerodynamic. The building is essentially screaming as it struggles to stay upright. What is the end game for a tower like this? There is no easy way out. You can't exactly demolish a 1,000-foot tower in the middle of Manhattan without causing a decade of disruption. But if the sinking doesn't stop, the building will eventually become a complete loss. Some experts suggest that the only way to save it is to take off the top 20 floors to reduce the weight. Imagine the conversation with the owners of those top 20 penthouses. Sorry, we need to remove your home to save the basement. It's an unthinkable scenario. But in the world of failing megaprojects, the unthinkable often becomes the only option left on the table. This situation serves as a wake-up call for the entire construction industry. We have pushed the limits of materials and height, but we are still limited by the planet we build on. The Billionaire's Row experiment has shown that even with the most money and the best technology, you cannot skip the foundational steps of engineering. If you don't respect the soil will eventually respect you by reclaiming your building. The cracks in the foundation of this $1.8 billion tower are more than just a repair bill. They are a sign that we have reached the limit of how far we can push our urban environment without serious consequences. As we watch this tower, we have to think about the labor that went into it. Thousands of workers spent years of their lives building a structure that is now in jeopardy. The sheer waste of human energy and natural resources is profound. It's not just a financial loss, it's a monument to wasted effort. Every ton of steel and every cubic yard of concrete represents a massive carbon footprint that was spent on a building that might be condemned before it is even 30% occupied. This is why mega-project failures are more than just news stories. They are reflections of our society's priorities. The legal battle will likely last longer than the building itself. With hundreds of millions of dollars on the line, every party involved is hiring the best experts to prove that it was someone else's fault. This creates an information blackout where the truth about just how dangerous the building is becomes buried in legal privilege. The public is left wondering if a 1,000-foot shard of glass is truly stable. This lack of transparency is perhaps the most concerning part of the entire failing mega-project. There is a strange irony in the name of the tower, which was marketed as something eternal and solid. It was supposed to be a legacy for the developer and a safe harbor for the buyer's wealth. Instead, it has become a symbol of volatility. In a world where we look for stability, the skyscraper that is literally sinking into the dirt is a powerful metaphor for the fragility of our systems. It shows that no matter how much we spend to project an image of power and permanence, we are always one bad geological survey away from total failure. Looking up from the street, you wouldn't know anything was wrong. The building still looks magnificent. It catches the afternoon light and glows with a golden hue that makes it look like the center of the universe. But the beauty is only skin deep. Beneath the glass is a structure in agony. Beneath the marble is a foundation that is crumbling. It is a hollow luxury, a grand facade that hides a terminal condition. It makes you realize that the most important parts of any building are the parts you never see. If you are a student of architecture or engineering, this tower is your most important textbook. It teaches you that your calculations are only as good as your data. It teaches you that when a developer tells you to make it work, despite the soil reports, your duty is to the structural integrity, not the profit margin. This $1.8 billion tower is a classroom for the next generation, showing them exactly what happens when shortcuts are taken on the most fundamental level of a project. The neighborhood around the tower has become a quiet zone. People don't talk about the building much, but they watch it. They watch the workers going in and out with heavy equipment. They watch the cranes that seem to stay on the site even though the building is finished. There is a sense of waiting. Waiting for the next big report. Waiting for the next loud noise in the night. Waiting for the moment when the city finally has to make a choice about the building's future. It is a slow-motion drama that is playing out in the most public way possible. In many ways, the tower is a victim of its own success. If it hadn't been so tall, the foundation would have been fine. If it hadn't been so expensive, they might have taken the time to do it right. But the pressure to deliver a record-breaking structure created an environment where warnings were ignored. This is the mega-project curse. The bigger the project, the more momentum it has, and the harder it is to stop when things go wrong. Once the first billion is spent, you are committed even if the ground is failing beneath you. The story of the sinking tower is still being written. Every rainy season, every windstorm, and every heat wave adds a new chapter to the stress on the structure. Will the grout injections eventually work? Will the new piles to the bedrock be enough? Or is this building destined to be a vertical ruins in the middle of the world's most famous skyline? We don't have the answers yet, but we do have the warning. The next time you see a massive skyscraper being built, don't just look up, look down. Think about the friction piles and the bedrock. Think about the water table and the clay. Because the difference between a monument and a failure is entirely in the ground. The skyscraper that started to sink is a lesson that will be remembered for 100 years. It stands as a 4 billion-pound reminder that you cannot outrun the laws of physics. Whether it's a house or a mega project, the foundation is the only thing that matters. Without it, you're just building a very expensive pile of glass. And in New York City, that is a mistake that nobody can afford to make. The tower continues to crack. The sensors continue to click, and the city continues to watch. It is a slow, silent, and incredibly expensive descent into reality. We can only hope that the brilliant minds working on the repairs can find a way to stabilize the giant. For the sake of the residents, the neighborhood, and the skyline itself, we want the tower to stand. But the lesson is already learned. Ambition is a powerful tool, but it is no match for the weight of reality. The $1.8 billion cracking tower is here to stay. For now, as a vertical monument to the importance of what's underneath. It is a failing mega project that we can all see, a beautiful but broken pillar that reminds us to always build on solid ground. Keep your eyes on the foundation, because everything else is just for show.